In 3.6, we're going to be looking at a bunch of perpendicular lines and some parallel lines. So Theorem 3.8, let's start out with this. It says that if two lines intersect to form a linear pair of congruent angles, then they are perpendicular. And I'm just going to use the perpendicular symbol there. So that upside down T again means perpendicular. So basically, if angle 1 is congruent to angle 2, then G, line G, is perpendicular to line H. Let's dissect this. So a linear pair, if you don't remember, is a pair of angles that are supplementary and adjacent. So linear means line these two angles. When you put them together, you get a straight line. So if you have a linear pair where the two angles are congruent to each other, well, that means that they add up to 180 degrees and they're the same. Well, the only way that you can get two angles to add up to 180 degrees and be the same angle is if they're both 90. So, obviously you could have a 100-degree angle and an 80-degree angle. That adds up to 180, but those are not the same angle. The only way that you can get them to add up to 180 and be the same is if they're both 90 degrees, if they're both right angles. That's what Theorem 3.8 says. Theorem 3.9 says that if two lines are perpendicular, then they intersect to form four right angles. And this is intuitive. If we have one perpendicular angle there, then they're all four going to be perpendicular angles. I think you can see that pretty well. But again, in mathematics, especially when we're doing proofs, we need to be very, very particular, very, very clear about what we were saying and leave absolutely no ambiguity in anything that we do. All right, so yeah, if line A is perpendicular to line B, then all four of those angles are right angles. Theorem 3.10, this is another one about perpendiculars. So it says that if two sides of two adjacent acute angles are perpendicular to each other, then the angles are complementary. So that's a bit wordy, but basically it's just saying if this side of this angle is perpendicular to this side of this angle, so if that's a perpendicular, then angles 1 and 2 are going to add up to 90 because that's a 90-degree angle there. So if ray BA is perpendicular to ray BC, then angles 1 and 2 are going to be complementary angles. Example 1, draw some conclusions. Line AB, that's this line right here, is perpendicular to line BC, that's the horizontal line. What can you conclude about angles 1 and 2? Well, if they are perpendicular lines, then we know that the angles have to be right angles. So we can conclude that angles 1 and 2 are right angles. And we could also conclude that they're congruent to each other. So if they're both right angles, then they're going to be congruent to each other because they're both right angles. Example 2. Find the measure of angle 1, that's this angle right here, given that this angle is 65 degrees. And then state the theorem applied. So this is a right angle here. We're told that on the picture. And so these two angles must add up to 90 degrees. So that means that this one's got to be 25 in order for them to add up to 90. And we can just take 90 and subtract 65 to get that. The theorem we used was Theorem 3.10 that says that if we've got two rays that are perpendicular to each other, which is what we have here, then the angles inside there have got to be complementary. Example 3. This is using the same theorem, 3.10. So we're told that FG is perpendicular to GH, and now we've got to find the value of X. Well, if this is perpendicular, that's a 90-degree angle there. And so that means that these two angles together must equal 90. So if we take that 63-degree angle and add to it X plus 14, then we should get 90. Well, we can combine like terms then. 63 and 14 are like terms. So that's X plus 77 equals 90. And then we can subtract 77 from both sides to get that X is equal to 13. Theorem 3.11, perpendicular transversal theorem. So again, if you don't remember what a transversal is a line that cuts through at least two other lines. And so what this theorem says is that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one. So what we can see here is that H and K, these two lines are parallel to each other, and we're told that this line J is perpendicular to line H. Well, if it's perpendicular to this line, then it must also be perpendicular to this line that is parallel to the first one that it's perpendicular to. So if H is parallel to K and J is perpendicular to H, then J must also be perpendicular to K. So if you've got some parallel lines and you have a line that's perpendicular to one of those parallel lines, then it must be perpendicular to all of the parallel lines. All right, then theorem 3.12 is lines perpendicular to a transversal theorem. So this one's kind of the reverse of what 3.11 said. So in a plane, if two lines are perpendicular to the same line, then they must be parallel to each other. So if M is perpendicular to P and N is perpendicular to P, then M must be parallel to N. So let's look at that on the picture. So it's saying if M and P are perpendicular to each other, and if N and P are perpendicular to each other, then it must be the case that M is parallel to N. Example 4. Is B parallel to A? So that's this line right here, parallel to line A right here. Are they parallel? Well, A is parallel to line D, and B is perpendicular, I should say. A is perpendicular because of this right angle here, and B is perpendicular because of this right angle here. So they're both perpendicular to line D, which means then, yeah, they have to be parallel to each other. Part 2, is B perpendicular to C? So that's looking at this intersection right here. Well, there's no marking there, so it might be tempting to say that no, they're not parallel or perpendicular, but in fact they are. So we have enough information here to say that they must be perpendicular. And the reason is that A and B are parallel to each other. We just found that out, that A and B are parallel to each other because they're perpendicular to the same line. And then also A and C are perpendicular to each other. So line A right here is perpendicular to line C. And so line B is perpendicular to a line that C is perpendicular to. And so, yeah, they've got to be perpendicular.